Welcome to part 70 of my video series on how to use Blender 2.7. In this video, we'll be talking about render speeds using the Cycles render engine. Now, it's no secret that you can get amazing looking results using the Cycles render engine in Blender, but it's also no secret that it can take a long time to render. So in this video, I'm going to be showing you several ways, several settings over here in the properties window that you can change, including using GPU CUDA rendering. We'll get to that later in the video. So your renders will take a lot less time to render each frame, which will amount to a lot of time saved, especially if you're rendering out an entire animation with lots of frames. If you want to follow along with me, you can download the exact file that I have on my screen right now in the description area below. And this file has a bunch of assortment of objects just sitting on a round ground. And if I break out of my camera view, you can see that I have 3 area lamps around my scene, so a 3-point lighting setup. And if I go back through my camera and change my viewport display shading to rendered, you can see that the sky color or the world color is white, giving us some nice global illumination. So this is what the scene basically looks like. Over here in the properties window, I haven't changed a whole lot because I kind of want to emulate what you would get, the settings you would have if you were just using Blender without having changed very many settings over here. The only few things I have changed are the output resolution, the X and Y, the width and height of the actual number of pixels that you would render out each frame to of your images or movie. I've set it to 1280 by 720. That's a common resolution, 720p on YouTube. And I've changed the number of samples in this file, the render samples, which reduces the graininess in the scene up to 500. So if I click on render in just a moment, you're going to see me render out this file. It will take several minutes, but every time I click on render, I will speed that process up for the sake of this video. In this video, I'm going to actually be rendering out this scene many times, each time changing just one setting over here. I'll be speeding up the renders. We'll see how each new setting change benefits our render speed. Then we'll put all those render setting improvements together and see just how far we've come from the default settings in terms of speed to how fast we can just get this render speed to get. We'll also be looking at, as I said, GPU rendering using NVIDIA CUDA technology, but right now I'm just going to be rendering out using my computer's processor, the CPU. Speaking of my computer, if you actually want to compare your render time results to mine, my computer is a Windows-based desktop computer. I have a Core i7-4790K processor. I have 16 gigabytes of DDR3 memory. I'm running my computer off of a solid state drive, and I have an NVIDIA GeForce GTX 970 graphics card. So let's go ahead now and click on render. I have not changed any of these settings as of the beginning of this video. So let's go ahead and click on render. I'll speed this part of the video up and you'll see how long it takes up here in this area, and I'll point that out once we finish rendering. Alright, through the magic of video editing, what seemed like just a few moments there in this video actually took my computer 4 minutes and 14 seconds. That's render number 1, 4 minutes and 14 seconds and a little bit of change extra to render out this single frame. Ouch. Before we go on to render number 2, I want to mention a few things, and we'll change one setting over here. The thing I want to mention is that to speed up your renders, the easiest thing to do is just choose the right version of Blender. If you're on a Windows computer and you're rendering out using a 32-bit version of Blender, when your computer is actually running a 64-bit version of Windows, you'll be sacrificing quite a lot of render speed there. So if your computer is a 64-bit Windows computer, go ahead and download the 64-bit version of Windows. You will see a significant amount of improvement in your render speeds there. Several years ago when I was rendering out an animation, I had a computer that supported Windows 64-bit, but I actually had Windows 32-bit installed on my computer, and I had, therefore, the 32-bit version of Blender, and I got a certain speed of render, and then when I switched over and actually reinstalled Windows on my computer to the 64-bit version and used the 64-bit version of Blender, my render speeds improved significantly on the exact same file. The one thing I'm going to change here now, the obvious thing, is the number of render samples. I have my render samples set up to 500. This is the setting that actually diminishes the amount of graininess in your scene. It's set to 500 right now, which is good for a production. A production might actually use anywhere between 200 and 5,000 samples depending on the actual scene and the quality that you actually need. But what I'll do here is I'm going to change my render output slot from 1 to 2, and that will leave me a blank canvas to render out to. And I'm going to change my render samples here to half of the original, so down to 250. This is the only setting I will change now. Remember that our original render time was over 4 minutes. Let's go ahead and click on render now and see how long this takes to render. Alright, so we finished rendering out render number 2, and our time was only 2 minutes and 6 seconds compared to render 1's 4 minutes and 14 seconds. Wow, what a difference. Now the reason I switched over to slot number 2 just before I clicked on render was so that we could compare our first result, if I go back to slot 1, to our second result in slot 2. Now we can't see very much difference at all, especially if you're watching this on YouTube, but if I go ahead and zoom into a darker area, that's typically where you see more noise in a scene. This is the amount of noise that we can see in our new render with only 250 render samples. And if I go back to slot number 1, you're going to see that it has a significantly less amount of noise. Now, it really is up to you how much noise you think is tolerable, but really if you're running out an animation, you might actually save yourself a lot of hours of rendering, especially if you're running out several minutes worth of frames at 24 frames per second. You might save yourself several minutes or several hours of render time depending on your needs and the number of samples that you actually need. So we improved our render time by about half just by cutting down the number of samples. But next I'm going to switch over to slot number 3 for our next render. I'm going to set the samples back up to 500 because the next way we can actually make cycles render a lot faster is by changing the tile size in our performance section under the camera tab in the properties window. If we go down to this performance section, you're going to see that our render tiles, those are the squares that render out when we're rendering out using the cycles render engine, are 64 by 64 on the X and Y axes. That means that our squares are 64 by 64 pixels. Now what this means for your computer, if you're rendering out using your CPU, is that each one of the cores or threads of your processor, in this case I'm using a quad core processor, but the processor actually has hyper-threading, so there are 8 hypothetical threads, that's what this number is here. Each of those threads has to process on its own 64 pixel by 64 pixel square. Now it turns out that processors are particularly good at doing multiple things at once, but you don't want to make them do any one thing for too long. So processors benefit from having a smaller number here, usually a multiple of 2. In this case, I'm going to go down from 64 for each of these values down to 16 and 16. So that's the only thing I'm going to change here. The tile size for my CPU rendering down to 16 by 16. Let's go back up to render. I've changed to slot number 3 and I'll click render and I'll speed this up. We'll see how long this takes. Alright, so render number 3 took only 4 minutes and 7 seconds, basically 4 minutes and 8 seconds. Remember that we're back for our samples, back up to 500, but that's still less than our first render, which is 4 minutes and 14 seconds, so a little bit of improvement there. You might see more improvement or less improvement depending on your specific scene. The next setting will change, but actually before I get there, I'm going to change my tiles back to 64 and 64. The next setting we're going to change are the light paths in our scene. Of course, when you have a scene and you have lights and you have objects, there is bouncing light around your scene and the light bounces into your camera. We can actually limit the amount of times that light is allowed to bounce, and that will significantly reduce our render times as well. So down here in our light path section, again in our properties window under the camera tab, we're going to set our max number of bounces from 12, which again is the default, down to, and you can choose 5, 6, 7, 8, 9, or 10, just a lower number. And by the way, yes, there are different types of bouncing lights. You'll see that transmission is set up to the highest value, but if you change this max value down to, in this case, I'm going to use 8 and press enter, it'll limit all of these values down to 8, which will really just turn transmission down from 12 to 8. But we should see an improvement there. Of course, I'm going to change my render slot now to the next slot, to slot 4. and we get a blank canvas. And now I'll render out again at 500 samples using our original 64 by 64 performance under performance tiles there. So if I click on render, we'll see how our result stands for this next render. Alright, so render number 4, wow, it just barely beat out our original render, which was 4 minutes and 14 seconds, and this render is in at 4 minutes and 13 seconds, so just 1 second better. Let's go ahead and compare it to the original. This is render number 4 with fewer light bounces, and then if we switch back to slot number 1, you can see really no difference. And yes, if you have a dark scene that relies on many light bounces, especially if you have like a dark room where you only have one light source and you're relying on like that light to bounce and fill out and light up little corners and crevices of your scene, you might see some differences. Or if you have glossy objects that are kind of reflecting onto other things with caustic lights, you might see some differences there. But in this scene, we're not seeing really any difference from slot 1 or render 1 and render number 4. But again, we only save just 1 second. Let's go ahead and switch over to slot number 5, and I'm going to change those light bounces under the light path section back up to 12. And it's at this point that I want to combine all the improvements that I've talked about so far in this video into one render. So the first thing I did was I changed my render samples onto the sampling section from 500 down to 250. We're going to see here just how fast we can get the render to go using my CPU before we jump over to using CUDA rendering using my graphics card. So we'll change the render samples down to 250. We'll change our light bounces down to 8. And under our performance section down here, we'll change our tile size from 64 to 16 and 16. I think those are the 3 things we have changed. I'm using the 64-bit version of Blender on a 64-bit version of Windows on my computer. Let's go ahead and click on render and see just how fast this render can go. Alright, so with all the different setting changes combined, we got a render time of 2 minutes and 3 seconds for render number 5. That's the best render speed yet, and of course most of that came just from the changing of samples. What I want to do now is switch over to talk about CUDA-based rendering. Now this requires that you have probably a Windows PC or a Linux computer that has an NVIDIA-based graphics card. As I said earlier in this video, in my desktop computer I have a GeForce GTX 970 graphics card. If you're considering buying a new PC, a Windows PC, I would highly suggest, if you're interested in using Blender primarily on this computer, that you buy an NVIDIA-based graphics card for your computer. My computer was built by a computer company called NCIX. I'm not sponsored by them, but they are a Vancouver and now a US-based company that will actually build you a custom PC using quality parts at a very, very reasonable price. Again, I'm not sponsored. I just really like my computer. It was very well built and the cable management was excellent. So the way that you get CUDA rendering to work on your computer and the settings that you're going to want to use, in fact, before I go any further, I'm going to change all my settings back. So I'll set my samples to 500. Under light paths, I'll set the max to 12, and under performance, I'll set, actually I'm going to leave those there because you'll see why in a moment. In order to use CUDA rendering, in order to use your NVIDIA-based graphics card to render, you might need to go, when you first get Blender, into the user preferences, and then under system, you might have to select on the bottom left your compute device, which by default might be set to none. In that case, it just uses your CPU, your computer's processor. If you switch over to CUDA, and then you might have to select your graphics card. Here I'm using a GeForce GTX 970, and if you have 2 graphics cards or even 3, I think you can use all 3 in Blender. That's great. If I click on Save User Settings now, and I close User Preferences, it's all ready to go, except over here under the Camera tab, I can change my device to GPU Compute. It is worth noting that I have installed all the proper drivers on my computer. These are all just the recommended drivers when you install your graphics card and you download the latest drivers from NVIDIA's website. At least for Windows, these are just the drivers that you would normally install just to use your graphics card. There's no special CUDA drivers that you need to get. It all just sort of works. Now, if you're like me and you get a new computer with an NVIDIA-based graphics card and you switch this setting over and you click render, but before I do that though, I'm going to change this to slot number 6, and you click render. Wow, oh wow, will you be disappointed? That render took over 36 minutes, several times the time that it took to render out using your computer's processor. So what happened? Well, I am purposely a few moments ago, or actually over 40 minutes ago now, and truth be told, this actually took so long to render using my graphics card that my computer actually kind of went to sleep and logged itself out. So I'm not actually sure if this is an accurate render time, but it's pretty darn close. The reason why it took this long is because of those tiles, and this is the key to rendering with your GPU, your NVIDIA-based CUDA GPU. The tiles down here in your performance section, 16 by 16, is the worst, or pretty much the worst thing you can use for your graphics card, and that's because graphics cards are not multi-threaded. They cannot do multiple tasks at the same time, but what they can do very well is one big task at a time very quickly. So if you notice there in that 3 seconds that I sped that video up, that 36 minutes down to 3 seconds, it was only running out one little square at a time, as opposed to when I was running out with my CPU, it was running out 8 squares, 8 threads, 8 squares at a time. There's a difference. So I'm going to change these tiles up to either 256. We're using powers of 2, not multiples of 2. I said that wrong earlier in the video, but powers of 2. And so 256 here again. And so now let's go ahead without changing anything else. We still have 500 render samples. We haven't changed our light paths down. They're still set to 12 there. So let's go ahead now and click on render. I'll change to slot number 7 though. So now we have a blank canvas. Let's go ahead and click on render. Alright, so as you can see, just by changing our tile size up from 16 by 16 to 256 by 256, our render time went down by leaps and magnitudes, down to 1 minute and 27 seconds approximately. So the tile size is what really matters when you're rendering out with your GPU. In fact, what I'm going to do here is I'm going to adjust one more setting. I'm going to adjust my tile size to 512 by 512. Sometimes you get better results with 256 versus 512. And one more thing I change here is the pattern in which it renders out the tiles. If you are rendering out with your CPU, you might notice that it renders kind of in a circle outwards, and that's called the Hilbert spiral. But CPUs tend to render out better when you have a simpler pattern, when it's not having to go and kind of do math and kind of figure out what the next coordinate is. If you just go from the top to the bottom, or starting in the center, I'm going to use top to bottom, it might be a little bit faster just to avoid those extra calculations of what coordinates it's going to start at next if you just go from the top to the bottom. So let's go ahead now and render out to slot number, in fact we'll just use slot number 7 again and compare our results. So I'll click on render. Alright, so in that case, by switching our tile size up to 512 by 512, we shaved about 1 second off our render time down to 1 minute and 26 seconds. For my last render, I'm going to combine all of the techniques I've talked about in this video into one render. So I'm going to switch over to slot number 8 now. I'm going to leave my device to GPU. I'm going to leave my resolution, but I'm going to change my samples down to 250. And I'm going to change my, actually I'm going to leave my tile size at 512, that seemed to work the best. I'm going to change my bounces, not down to 8 this time, but actually down to 6, because we might actually get faster results and more of a benefit that way. Let's go ahead now and go to the top, and this will be our very last render of this video. So let's go ahead and click on render. Alright, that was the quickest render yet. Our render only took about 43 or 44 seconds. That's about 5 or 6 times faster than our original render result. If I compare the two, this is in slot number 8, this is the last render we just did, compared to the render in slot number 1. Yes, we have fewer samples, but really at a glance, especially if you're rendering out many frames in a row, you're going to see a huge benefit to rendering out with a GPU rather than your CPU and with some modified settings. The last thing I'll say in this video is that in part 46 of this video series, I made a video on eliminating fireflies or render noise. And in that video, you're going to see some more techniques that just coincidentally actually happen to speed up your renders as well. These techniques are to do with bouncing light in your scene and getting rid of reflections and caustic lighting. That happens when you actually have a glossy surface that's bouncing off a light onto other surfaces. So go ahead and check that video out if you want to speed up your render times even more. But that will be it for this video. Please don't forget to like this video and subscribe to our channel to see more videos just like this one, and check out my Facebook page at facebook.com/borncg. But that'll be it for this one. Thanks. Bye-bye.